In this video, we are going to talk about the two standards that go with our rounding whole numbers unit. Both of these are supporting standards, but they are both critically important to developing a student's number sense and understanding of the magnitude of numbers. So we have 3.2C and 3.4B. In 3.2C, our students are required to represent on a number line. This is critical because we as adults tend to think about teaching rounding in a lot of ways, rarely with a number line. Students make so much more sense of rounding when they put the numbers on a number line because they have something to relate it to. It gives them something that's pictorial instead of quite so abstract. So the standard says represent on a number line as being between two consecutive multiples of 10, 100, 1,000, or 10,000, and use words to describe the size of numbers, or the relative size of numbers, in order to round them. Not we teach them other strategies to round. We do all of these things in order to round. So we're not teaching tricks. Here's why it's so important that we're not teaching tricks for rounding. Students we see in every grade, teachers say, students don't have any number sense. Their number sense is so lacking. How do we help their number sense? A lot of the time we help their number sense by helping them understand the size of numbers. Helping them understand the magnitude helps them make that number sense a little more real to them. So we're not teaching tricks or songs. If we think about how a student learns, we learn by building on what we have prior experience with. So if I am a third grade student, which is the first time I ever learn rounding, so second graders have no rounding standards. So you're introducing it for the very first time. If the very first time I experience something, my teacher teaches me a trick to be able to do it, a song, let's say, because there are 1 million different songs out there for how to learn how to round, follow rounding rules. And then I go to fourth grade, and my fourth grade teacher has a different trick or a different song. And then I go to fifth grade, and my fifth grade teacher has a different trick or a different song. As a student, as a child, their brain thinks all of these experiences are new learning. They don't make the connection to what did I learn in third grade that I can then apply in fourth grade. They think I learned this in this third grade silo, and when I get to fourth grade, I learned this in this fourth grade silo, and I know nothing about it from third grade because I'm being taught in a different way. So we tell fourth grade teachers, third grade teachers teach students to round on a number line. And then when they come to fourth grade, we can make the connection to the third grade standard of rounding with a number line. So let's talk about what that looks like. Let's say that I want to round the number 159 to the hundreds place. Now, if I'm rounding to the hundreds place, I need a number line that has the 100 before this and the 100 after this. So I would need 100 and 200. I need to know where the middle is. So this is a great time to make that connection to money. What's halfway between $1 and $2? $1.50. So what's halfway between 100 and 200? 150. Where does our number 159 fall on this number line? Well, probably right about there, 159. So which is it closest to? Is it closer to 100 or 200? It's closer to 200. See, what we are missing as adults is rounding is a distance question. It always says, what is it closest to? Close is a distance. We can find the distance on a number line. I can see very easily as an 8-year-old, what is it closer to? I didn't have to look at this place, and if it's 5 or more, do this trick, and if it's not, do this trick, and do I have to remember what to do with the 5? I just put it on a number line, and I can visually see what is the number closest to. So I would know 159 rounds to, or is approximately equal to 200 if I'm rounding to the hundredths place. That's all they have to do. 2 consecutive multiples of 10, 100, 1,000, or 10,000 just means I'm not going to give them 500 and 1,000 and ask them what does 863 round to. I would give them 800 and 900 because that's the hundreds that it could round to. If I was asking them to round to the thousands, I would give them 0 and 1,000 because that's consecutive thousands. No thousands or 1,000. So 2 consecutive multiples just means I always find from the place that I'm rounding to, the hundreds place, what's the 100 right before this, what's the 100 right after it. These 2 are consecutive hundreds. And then I use words to describe the magnitude or the size. 159 is closer to 200. 143 would be closer to 100. So I'm using words to describe that. Now, in our standard 3.4b, which is also let me go back to one thing before I move on. In 2nd grade, there are no rounding standards, but students do work with an open number line. So they start that in 1st grade, actually. So they are used to finding the numbers that would go on either side of this to put on a number line. So 1st and 2nd, they have experience with open number lines and locating a point on a number line. So this is not new to them. It's just they have not used it to round, so they haven't applied it that way. So they have found a point on a number line. So that way you can see it a little bit better. Okay, so they do have some knowledge of number lines, they just have not applied it to rounding. They've applied it to a lot of other situations, just not rounding. Okay, so now let's talk about rounding in a problem-solving setting. So in 3.4b, students are asked to round to the nearest 10 or 100 or use compatible numbers. They can also use compatible numbers. And we'll talk about what that means and why that would be okay. To estimate solutions to addition and subtraction problems. So if I'm asking students to round to the nearest 10 or 100 to estimate solutions, I'm not telling them where they have to round it to. I'm wanting to build that understanding of what is reasonable. So we're really focused on what is the reasonableness. And in this standard, the only thing students are going to have to draw on is what we do in this 3.2c, because they don't round in 2nd grade. So then they've certainly never used it in a problem-solving setting. So if I have a problem and I'm asking them to round to the nearest 10 or 100, I'm not telling them what place they have to round to when we're talking about problem solving, and that makes kids uncomfortable. That's where compatible numbers comes in, because we're allowing students to decide what makes the most sense for them. So for example, if I wanted to say you're the teacher and you have 34 red counters and 63 blue counters, and you want to know how many do you have total. Well, I could do a couple of things to solve this. I could say this is close to 30 and this is close to 60, so it's about 90. But I could also say this is about 35 and this is about 65. And that's compatible. Those are easy to add together. That's all compatible numbers mean. They're friendly. They're easy to work with. So I could then add these two together and say it's about 100. Either of these are reasonable answers. So they're not wrong. So here's the thing, when we're asking students to round to estimate solutions, we don't have to follow specific rounding rules. We can round to the tens or hundreds place, or we can use compatible numbers, and all of it is accurate. So we would want to have a conversation with kids about, why would both of these be okay? Well, we could find the actual solution and say, well, they're both okay because they're both really close to the actual answer. Estimation is not designed to give us an exact answer. It's designed to get us in the ballpark. We want to be in a close ballpark. We don't want to say, well, this is close to 0 and this is close to 100. That wouldn't make sense. But we could round to the tens, or we could use compatible numbers, and both of these get us a reasonable answer. Now, the other thing that we see kids struggle with in this particular standard, when they're not told what place to round to, they like to just add them up and then round. So we do not add and then round. We always estimate before we operate. Always. Think about it like going to the store, and I want you to relate this to kids. So let's say your student walked into McDonald's and they had a $10 bill. They would want to figure out before they got up there to place their order about how much their food was going to cost, so they would know if they had the right amount of money. If I walk up and I've ordered $15 worth of food and I only have a $10 bill, I have a problem. So I would want to look at the prices of what I want to order and estimate about how much is it going to cost before I walk up to place my order. When I walk up and place my order, the cashier is going to tell me exactly how much, and then I can pay and get my change. But I already know about how much is it going to cost. Kids also like to think about this from the standpoint of, if I go up and I know about how much it's already going to cost, then if the price that they give me is way away from my estimate, then I can think, did someone make a mistake? Are they trying to cheat me? That's what kids like to say. We always want to know about how much before we operate, so that we know if our work is reasonable. So when we are working with rounding, then we're looking for a reasonable answer. Then we can bring this into problem solving when we're not asked to round, and we can talk about, okay, if we were to get a ballpark answer, what do we expect the answer to this problem to be close to? And we would come up with an estimate. Then we solve the actual problem to make sure that our actual answer is in the ballpark of what we were expecting. So then rounding becomes one really big life skill for us, because we use it all the time when we're shopping. We use it all the time when we're paying for things. So we want to teach kids how it's applicable, and then we use it in problem solving, so we help to build that reasonableness that we know our students need work on.